College Algebra kids. We are finally finished with all of our content for the course. So this is our study guide for Chapter 4. So you're going to find the study guide very short because your test is very short. Your test is only 13 questions. There are no bonus questions simply because you're taking it home. So while you're at home, you are able to actually get more help, of course, than you would in class. So that's your bonus. But the practice homework problems are still available for the +5 bonus points. So if you want to go on My Math Lab and complete those, it will definitely help your grade. So there are no problems from section 4.5. So my haters of word problems don't have to worry about that. But let's jump right in and just go over this. Make sure you have a calculator with you. That's going to make all the difference. So I'm not going to use any of my fancy calculator buttons. I am going to use my fancy calculator, but I will treat it just like you would your regular scientific calculator. So here we go. Number 1 wants you to approximate the following number using a calculator. That just means put that into the calculator. So here we go. Here's our calculator. I'm going to put in the base, which is 5. I'm going to use this little button here to raise it up higher. So I used this little caret button. And I'm going to put in -1.2 and hit enter. And then I'm going to round it to 3 decimal places. So I'm going to have 0.145. And that's going to be my answer. That's all they want. So in your calculator, you're going to take the base. You're going to use that little caret button. Sometimes you may see it as this button. It's the same thing. Then you'll do a negative. That's not a subtraction. Make sure it's a negative. 1.2. And you should end up with 0.145 because you want to round it to 3 decimal places. And that's your answer. Okay. Now, number 2 is a very long problem. It actually has 4 parts. So this pertains to these interest formulas that we talked about. So we have this formula that you're going to use, and we have this formula. How are you going to know which one to use? This one that says like the PERT, the P-E-R-T, you're going to use this if you see the phrase continuously compounded. That's how you know to use that one. If you don't see this, you use this one. This is for everything else, okay? So continuously compounded, this is for everything else. Okay, now we have some other information. First of all, it says find the accumulated value. Well, that's just A, so you're going to be solving for A. Of an investment of $25,000. This is P. That means your beginning amount, your principal amount. So if we're using this formula, it goes there. If we're using this formula, it goes here. Okay. For 8 years, this is T. This is your time. If we're using this formula, it's up here. This one, it's up here. So either way, it's an exponent. Okay. And then it says an interest rate of 3%. 3% is your R, but we can't put it in as a percent, so we have to divide it by 100. When we do that, we get 0.03. This is your R. So if we're using this one, there it goes. If we're using this one, there it goes. Excuse me. Oops, that wasn't planned. Sorry about that. It's not the corona. Okay, so we have our info. All right, now we have 4 parts. We're going to have A and B on this page, and we're going to have C and D on this page. On your test, it will be the same. You will have this initial information, and then you'll have 4 parts to the problem. So this is all one problem, okay? All right, so A wants to know what is the accumulated value, meaning A, if the money is compounded semi-annually. All right, well, first of all, this tells us two things. It does not say continuously compounded, so it has to be this formula. That's the first thing. We have to identify what formula we're going to use. And since it doesn't say continuously compounded, we're using this guy. This semi-annually tells you what n is going to be. Notice this one doesn't have an n. This one does. Semi-annually, the n wants to know how many times a year is semi-annually. Well, that's 2 times a year. Okay, so now we have all of our information. We have R, P, T, and N, and we're going to plug it right in here. We're going to take our time. All right, so we said our P is 25,000, parenthesis, this is a 1, plus our rate. Remember, we had to turn it into a decimal. Don't put 3, put 0.03. Divided by N is 2. Okay, now up here as an exponent, I have N times T. Okay, so there we go. So N shows up in 2 different places. That's really important. As we go through the problems, the only thing that's going to change is N. So you're going to have to change 2 numbers. Okay, all right, here we go. First thing I'm going to do is put this little number into my calculator, the 0.03 divided by 2. I'm going to take it one step at a time, okay, because I don't want to overwhelm your little calculators. All right, so I get my calculator back out. Okay, here we go. We're going to put it over here for a sec. All right, I'm going to take 0.03 divided by 2. All right, that's what's going to go right here. And then I know 2 times 8 is 16. Okay, so that's what I did. I divided this and I multiplied the exponents. Okay, now I'm going to combine these two. Just taking it one step at a time. 1 plus 0.015 is 1.015. Okay, now I'm ready to find A. So I'm going to do this part first. I'm going to take 1.015, raise it to the 16th, get that answer. Then multiply it by 25,000. So here I go. Whoops, clear it out. I'm going to have 1.015. I'm going to hit that little caret button again to pop it up. That's being raised to the 16th power. There it is. Then I'm going to multiply that by 25,000. And here's what I get. Now we want to round it to the nearest cent. And with money, that means 2 decimal places. So I'm going to round this to 0.64. So my final answer is 31724.63. Now normally, if I were just doing this problem in class, I would put a money sign here, a dollar sign, and a comma, but we're practicing for my math lab test. My math lab does not want a comma or a money sign. Okay, so just put it in just like this for my math lab. Okay, so we took it one step at a time. We did this division first. We multiplied the exponents. We added. Then we took this number in parentheses, raised it to the 16th power, and then multiplied that by 25,000. You could do 25,000 times this raised to this. Just be careful. Make sure you're getting this value. We don't want to do anything out of order that might give your calculator the wrong idea. Okay? All right, step B. What is the accumulated value if the money is compounded quarterly? All right, again, doesn't say continuously, so we're back to this formula. Okay, more practice. Here we go. Now, we're going to keep the same P, T, and R. What's going to change is N. N is how many times a year it is compounded. This says quarterly, which means 4. Okay, so here we go. We are going to still have 25,000 for P. There's our 1 plus. Our R did not change. What did change was N. Remember, an N's in 2 places. So we're going to have a 4 here, and we're going to have a 4 here multiplied by 8. All right, now we're going to take our time. we're going to do 0.03 divided by 4. Here we go. 0.03 divided by 4 is 0.0075. That's what's going to go inside here. 4 times 8 is 32. That's a huge exponent. That's okay. All right, now we're just going to add together what's in the parentheses. Whoops. So if I add 1 to that, I get 1.0075 raised to the 32 power. Okay, now I'm going to take my 1.0075 raised to the 32 power, and I'm going to multiply that by 25,000. There's my answer. Again, I'm going to round to 2 decimal places. Okay. A equals 31752.78. No dollar signs and no commas. Now here's a little check for you. As your N increases, so should your money. So as you're going through this problem, your N is going to get bigger and bigger as we go. Make sure that your answers get bigger and bigger. Just be a little bit, but make sure they're increasing as we move along. Okay? All right. Let's go do C and D. Okay? All right, here's C and D. So we want to remember that our original principal amount was $25,000. Our T was 8 years, and our rate was 0.03. So we want to remember those items. They still apply for C and D. Okay, C says, what is the accumulated value if the money is compounded monthly? Well, it doesn't say continuously, so we are still using this formula. Hasn't gone away, still using that formula. Now that we want to compound monthly, N is how many times a year that is. Well, there's 12 months in a year, so N is 12. Okay, now our N increased even more than what we were used to. So this amount should be larger than A and B. Okay, so we're getting bigger as we go. Remember, that's your checkpoint. Okay, let's fill in what we have. We have our 25,000, 1 plus 0.03 divided by 12, and then we have 12 times 8. Okay, so the N is in 2 places again. Okay, we're going to take it one step at a time. I'm going to do 0.03 divided by 12 this time. I get 0.0025. Okay, and then 12 times 8, which is my exponent, is 96. It's a huge exponent. It's why your amount is going to increase. Okay, let's add together the 1 and the decimal in the parentheses, and you get 1.0025 to the 96 power. Okay, in my calculator, I'm going to have 1.0025 raised to the 96 power times 25,000. There we go. We're going to take 2 decimal places. So 31771.71. Okay, let's just make sure this is bigger than this amount. It sure is. So we should be on the right track. Okay. All right. Last but not least is D. D says the money is compounded continuously. Remember, that would be your PERT formula. We finally switched formulas now. So finally, we are going to use this formula. Notice there is not an N. There's no N, okay? All right, let's fill in what we have. P is still 25,000. Now remember, E is a button on your calculator. So we're gonna have to use that button on our calculator. And E is gonna be raised to the R, 0.03, times T. R times T. There we go. Okay, well, first thing I like to do is multiply my r times my t. So I'm going to do 0.03 times 8. That gives me 0.24. All right, that gives me a nice little exponent. Okay, now I like to do e raised to this decimal. So here's my e. It's hidden right by that natural log, by that ln. So I'm going to have to hit second ln, and then notice my e pops up. I'm going to raise it to the 0.24 power. Then I'm going to multiply it by 25,000. And there's my answer. I'm going to round it to 0.23. So I get 31781.23. And that should be the largest number of all. Sure enough, it is. So as we move through, your numbers on this problem, answers should increase, and they do all the way. And this compounded continuously is the only time we use that PERT formula. And there you go. Okay, now we're finally going to move on to number 3. Okay, number 3 can be done 2 different ways. Okay, now this wants you to evaluate the expression, so it wants the answer, it wants a number. This says without using a calculator. Okay, well, there are not calculator police watching you, I can assure you of this. So if you want to use your calculator, no one is going to know. Okay, so you can always do that, it'll be fine. So let's do it both ways just to make sure we're comfortable. So first way we could do it is without. So we're going to set this equal to y. And we're going to make it an exponential. We're going to start with the base of 2 and raise it to the y. This is going to come over the top and equal 1/8. Now we just have to figure out what on earth is y. Well, I know that 2 cubed is an 8, but this has the 8 in the denominator. So what exponent is going to give me 1/8 instead of 8? A negative exponent would do that. Y is actually a -3. That is your answer, because a positive 3 would put the 8 in the top. A -3 would put the 8 in the bottom. So there you go. Now, if you wanted to do this on your calculator, okay, if you have the fancy calculator like I do, okay, if you have the TI-84 Plus, or if you have a plus after it that you can try this on, what you're going to do is hit alpha, window, and this little window pops up. And you go down here to log base, and you get this nice little log, and you just fill in the blanks. You put a 2 down here, and you put a 1/8 here, and you hit enter, and look at there, -3. Now, if you don't have one of these fancy calculators, that's okay. We're going to do a change of base formula. We're going to do a regular plain old log of the argument, which is 1/8, divided by a regular plain old log of the base. Okay, so if I do that, I'm going to do this plain old log of the argument divided by plain old log of the base. And look there, I get a -3 either way, okay? And you don't even have to do that in one full step. If you want to just find the log of 1/8 first and hit enter, then divide that by the log of the base, you can do that. Either way, you should end up with -3 as your answer. So this -3 is what they want. Okay, number 4. Number 4 wants you to do 2 things, okay? It wants you to write this in its equivalent exponential form, then solve for x. So it wants 2 things. Okay, first we're going to write it in exponential form. We're going to take our base and raise it to the other side. That is going to equal the argument. And we don't need those parentheses because there's nothing else over there. So this is exponential form. Done. Now, if we're going to solve for x, we have to solve this. So 2 to the 4th, you can put that right in your calculator. 2 to the 4th is 16. I'm going to have 16 equals x plus 5. I'm going to subtract 5 from both sides, and x equals 11. Okay, and that's your answer. So here's exponential form. This is you solving for x. Okay. All right, here we go, number 5. All right, for number 5, this wants you to expand the logarithmic expansion. So you have an argument with a division in it. Remember, this actually means there's 2 logs and they are subtracted. Okay, so first thing we're going to do is write log base 5, because you have to keep your base the same, of the numerator. Division means subtraction in log world. Log base 5 of the denominator. Notice the log 5 stayed the same. Numerator minus denominator. Now we're not done, because it says where possible, evaluate. Now we don't care about the calculator portion, but evaluate. That means if either one of these can be put in the calculator and given a whole number, do it. Now this is not going to give you a whole number because we have a letter. How can that possibly work? So this side is going to stay. This is the part we need to investigate. What could the answer to this be? Okay, well, if you wanted to do it without a calculator, I'm going to set it equal to x because we're using y over there. You could do 5 to the x equals 25. 5 to what power equals 25? 2. So this is actually equal to 2. And this would be the answer that they want, just like that. Now you could also put this in your calculator. So I could do regular log of the argument divided by regular log of the base. There's that 2 that we came up with. Could put that right in here for that, minus log base 5 of y. So make sure that you do that. Make sure you realize this is actually a 2-part problem, okay? You will end up getting half of that problem wrong, or maybe even the whole problem, depending on my math lab, so be super careful about that. Okay, this one just wants you to condense. So you have 2 logs, and it wants you to write it as 1 log. Well, it also wants to make sure the coefficients are 1. Well, I have a coefficient of 5 for this guy and a coefficient of 8 for this guy. So if you remember your log properties, coefficients actually become the exponents of the argument. So I can write this over as log base A of x to the 5th plus log base A of z to the 8th. Okay, so I wrote it over, and now they each have a coefficient of 1. Now I'm going to write it as a single log. Okay, so log base A, notice my base didn't change. Up here, division meant subtraction. So I hope you remember that addition means multiplication. There we go. You can leave it just like that, or if you wanted, you could put parentheses around that argument. That's your decision. But make sure that you have 1 log with a base of A, and that you have x to the 5th, z to the 8th. Make sure you realize this is z. It's not y. Normally we do x's and y's. Be really careful on that. If you put the wrong letter in, my math lab will get you. Okay. All right, number 7. Number 7 has all these long directions in it. All it wants you to do is put this in your calculator. That's all. It's not going to be a whole number. It's going to be a decimal, and you're going to round it to 4 decimal places. Okay, so here we go. If you have the fancy calculator, you can do the alpha window and go right on down here and put a base of 8 and an argument of 12, and there's your decimal. Or we can do the plain log of the argument divided by the plain log of the base. So 12 on top divided by log of 8 on the bottom. Going to give you the same decimal. We want 4 decimal places, so 1, 2, 3, 4, okay? This 8 is going to bump the 9 up to a 0, which means the 4 goes up to a 5. So we end up with 1.1950. Make sure that you round that correctly. And there you go. All right, we are almost done, believe it or not. Okay, now we get into equations, solving some equations. So we want to make sure that you're really comfortable solving equations because that's basically the rest of the test. Okay, all right, here we go. This page, 8, 9, and 10, involves exponential equations. So what we want to do is get the variable out of the exponent. Okay, now if you recall, there's 2 methods to doing this. Method 1 is to express each side as a power of the same base. Okay, method 2 is to express each side in terms of the natural log or the common log. Well, this is method 1 because it tells you to make them the same base. Okay, plus we know that 5 and 125 have something in common. We know that 5 cubed is 125. So I can actually replace 125 with 5 cubed. This is going to make sure that I have the same base. There we go. Okay. Now that we have the same base, I'm going to cancel that same base. Now, not the 3, because they don't have that in common. I'm just canceling the base, the 5. I'm going to end up with an x plus 1 on the left, and I'm going to have a 3 times 2x minus 3 on the right. Now notice I'm going to have to distribute this 3 through here. That's the key. Okay. Now I'm going to have x plus 1 equals 6x minus 9. And I'm going to solve. I'm going to subtract my x from both sides, and I get 1 equals 5x minus 9. Okay, I'm going to move this up here. Then I'm going to add 9 to both sides, and I get 10 equals 5x. Divide 5, x equals 2, and there's my answer. Okay, so the trick here is to read the directions. It tells you to use the same base. Then I somehow need to take these bases and make them the same. Take the bigger one that you see and turn it into a version of the smaller one. So 125 is the same thing as 5 cubed. So I took this bigger one and I got rid of 125 and I wrote 5 cubed instead. It still has this little exponent here. Then the 5's cancel. This comes straight down. Still have my 3, and then I've got to multiply it through the rest of that exponent. I have to distribute it, and then I just solve it like a regular linear equation, and I end up with that. Okay. All right. Now, number 9 doesn't give us that option. This doesn't even tell us to use the same base. This tells us to use natural log or common log. That's because there's no way I can turn 127 into a version of 2. There's no 2 to the 8th or 2 to the 7th that's going to give me 127. So I cannot make these bases the same. Okay, this wants 2 answers. 2 answers. Make sure that you provide them with 2 answers. First, express the solution set in terms of a log. Okay, in terms of log, all right? Then use a calculator to obtain a decimal approximation. All right, So first thing we want to do is take the log of both sides. Now you can take the natural log of both sides or a regular log of both sides. There's really no advantage to either one. If this were an e, we would take the natural log. If this were a 10, we would take the common log. Since it's neither, there's really no reason to take either one. It's really up to you. I think my math lab usually takes the common log, the regular log, so I'm going to do that, but it really does not matter, okay? You'll get it right either way, and I'm going to go back and check your answers because I won't let my math lab mess with you. I'll make sure that you get credit. Okay, so I took the log of both sides. The reason I did this is because I have to get this exponent down, okay? How do I get an exponent down to the regular level? Well, the properties say it becomes a coefficient. So now I have x times the log of 2 equals the log of 127. Now I want to solve for x, so I'm going to divide both sides by the log of 2. And I'm going to get x equals log of 127 divided by log of 2. And that's as reduced as you can be. These problems on this test, I'm not thrilled with these. I did not make this test, but I have to give it to you. I don't have a choice. They're tricky. That's why I wanted to go through these with you. Do not get reducing happy on me and start reducing everywhere. There's nothing to reduce. This is it. Okay, this is it. So you have expressed the solution set in terms of logs. Done. Okay, second part, use a calculator to obtain a decimal. Now I didn't write it on here, but it is out to 2 places. Check your My Math Lab, it'll tell you how many places, but we're gonna go with 2. Okay, so here's what we're gonna do. We're just gonna put this right in our calculator. Okay, so I'm gonna have log of 127 divided by log of 2. There's my answer, 6.99, because I'm only going to go out 2 decimal places on this. 6.99. All right, and I did it. We have both. I think this might even give you like a little approximate little squiggly sign there, but that's okay. All right, let's try it again down here. Solve the following exponential equation. Express the solution set in terms of logs. Okay, just like this. Then use a calculator to get a decimal. All right, well, this is our exponential term. This exponential term was already isolated, so I didn't have to do anything to it. But on this one, I still have this -4 hanging around, so we're gonna add him to both sides. We wanna make sure we're isolated. We want that e term all by itself. There we go. Okay, now I need to take the log of both sides. I can take the natural log or the common log. Being that this is an e, your life is going to be so much easier if you take the natural log of both sides. So remember, that's the ln. You have to do it to both sides. I know that's a weird looking sight, but that's what you're going to be doing. Okay. Now, the reason we chose natural log is because remember what his super secret base is for ln? It's an e. And remember what happens if this base and this base are the same? These cancel. So I'm left with this exponent that comes right on down equals the ln of this other side. All right. Let's move it up here so we have room. Okay, here's where you're just really going to have to suppress your overwhelming urge to reduce things, because from this point on, you cannot reduce. So it's going to look super weird, but you can do this. Be strong. Okay, we're solving for x. So we're going to add 2. All right, here's the thing though. These are not like terms. You cannot combine them. This big old number here is the argument of a log. You can't just suddenly break in there and add 2. So you are going to have to leave these separate, just like that. You cannot combine them. Then I'm going to divide the whole thing by 3. I told you this gets really strange. Okay, so we end up with this divided by 3, and that is your answer in terms of the natural log. So pretend this was a root. If this were all under a radical and I said add 2, you couldn't go inside the radical and add 2. You would just stick it on the outside. Well, same thing here. If you don't like this and you want to write it as 2 plus the natural log like that and divide by 3, you can do that if that's easier and it doesn't tempt you as much. If you want to add the 2 in the front, it really doesn't matter as long as you do not combine them. Now, we were able to add 4 over here because we didn't have a log yet. We just had a plain old number. A number plus a number is another number. Okay? All right, now we also have to use the calculator, so we're not done. We have to be able to put this in our calculator and not mess it up. So here we go. Now we're going to take the natural log of 32184, enter. Then add 2, enter. Then divide by 3, enter. I took 3 different steps and I came up with 4.13. Okay, make sure you can get this number. I did not just throw this all into my calculator. I was very deliberate about it and making sure I did this part first, got an answer. Added 2, got an answer. Divided by 3, got an answer. Make sure that you do that, okay? And this should be your answer here, final. All right, last page. Still on equations, but this time we have log equations. 3 log equations and we're all done. Okay, well, here we go. Get my little solution set over here ready to go. Okay, so let's read our directions. Now, solve the following log equation. That's the same for all. The next sentence is also the same. Be sure to reject any value of x that is not in the domain of the original. That is the same sentence for everyone. Remember, your argument must be positive. So when you find your answer, plug it back in and see what happens. Is your argument still positive? Okay, that's super important. If it's not, then you're not going to use that answer. Okay, all right, here we go. This says give the exact answer. Then, so it looks like we're going to have 2 answers here, guys. Give the exact answer. Then use a calculator to obtain a decimal approximation to 2 decimal places. So 2 answers for number 11. Okay, first thing we're going to want to do is we want to isolate this log term. So we are going to subtract 6 from both sides. Okay, now we're going to divide by 2. And I get the ln of x equals -1/2. Okay, well, how in the world am I going to now get this argument out of here? How am I going to figure out what this is that's going to give me -1/2? Since I have a natural log, I'm going to take e of both sides. That's what I'm going to do. So if I take, I'll put it up here, the e of ln of x, okay, well, that's not what I'm going to do. I can't believe I just said that. This is what's happening to me. Erase that. Don't ever mention it again. That's ridiculous. That's not even real math. Okay, here's what I'm going to do. Back that up. I don't have my front row here, and I don't have some of your little faces to go, Ms. Holcomb, what are you doing? Okay. All right, remember, there's the super secret base here. I knew E was involved somehow. Okay. I'm going to take this super secret base. I'm going to write it in exponential form. I'm going to take E to the negative 1/2 equals X. There we go. Now this is our answer. This is that first answer, the exact answer that it wanted. How do I know to stop? Because I have X all by itself on one side. I did it. And this is just a number. Remember, E is in your calculator. Now I want to use that calculator and get a decimal approximation. So I'm going to clear this out. I'm going to do second natural log, there's my E, to the negative 1/2. That's going to give me a little approximation of 0.61. It only wants 2 decimal places, and I'm done. Okay, I cannot believe I just did that. I got to pay more attention here. Okay, so we isolated ln of x. We know that the super secret base is E. Now we're just going to take that E, raise it to this side, equals X. You're done. Oh, I forgot to do one last thing. I forgot to check and make sure this worked in my argument. If I take 0.61 and I put it inside here for X, well, sure enough, 0.61 is positive. It's positive right there. This works. Now, what if this had come out to be negative 0.61? If I put in negative 0.61, that argument is no longer positive. If this were negative 0.61, I couldn't use it, and I would have to put no solution. Okay, so we have to be careful about that. Okay, moving on. Number 12, here we are. Solve the following logarithmic equation. Here's that little disclaimer about the domain. Give the exact answer. Okay, so we're only looking for an answer here. We don't have to do 2 like we did here. Okay, so I have a 1 over here. There's nothing I can do on that side right now. I have 2 logs over here. Well, I'd really like to have just 1 log. So I know that I can condense these, right? I can make 1 log with a base of 9. And then since they're added together, I'm going to take their arguments and I'm going to multiply them. And that equals 1. Okay. Now what I can do is write this in exponential form, just like I did here. I have a base. I'm going to raise it to this power, set it equal to this whole argument. There we go. Now this argument is going to have to be distributed. It's going to have to be worked on. I could have done it here, or I can do it here. Okay, I'm going to go ahead and do it now. So 9 to the 1 is just a 9. I'm going to distribute this x. I get 8x squared minus x. Okay, guys, this is looking a whole lot like a quadratic to me. So I'm going to subtract my 9 over to here, and look there. I'll go ahead and put my 0 here. That is a quadratic equation. Okay, so now we're going to solve for x. You can put that in the quadratic formula, or you can factor. I'm going to factor. Since this is not a 1, I'm going to have to take it multiplied by the last term. That's a negative 72. I want factors of negative 72 that are going to add together to give me negative 1. Well, I already have one in mind. I have a positive 8 and a negative 9. Those multiply to give me negative 72. They add to give me negative 1. I'm going to replace that middle term with these. There we go. So I just put little x's here, and I replaced this middle term with those. Now I'm going to group. There we go. I see a GCF here of 8x. I'm going to pull out. I see a GCF here of negative 9. I'm going to pull out. These are the same. Write that down. followed by 8x minus 9. That's what's left. Okay, if I set both of these equal to 0 and solve, I'm going to have x equals -1. And I'm going to have x equals, I would add my 9 to the other side, divide by 8, 9/8. Now I'm not circling both of these. I have to put them back in and check my arguments. Okay, if I put a -1 into this argument, it becomes negative. That's a no-no. I cannot use this at all. And I don't even have to check the second one, but if I did, 8 times -1 is -8 minus 1, -9, it's also negative. Okay, let's try 9/8. If I put a 9/8 here, that's positive, that's good. If I take 9/8 times 8, that's a 9, minus 1, that's an 8, that's positive. This one works. That's my answer. Now, if they both worked, they would both be my answer. This is the only one that did, so that's it. That's all I write. If neither one of them worked, if they both made these negative, I would put no solution. So once you find your answer, you have to put it back in and make sure the argument is positive. That's important. Okay, last one. Here we go. Same directions as number 12, so we're looking for just one item. We don't have to have two like we did up here. Okay. So again, I see 2 logs on the same side with the same base. That means I'm going to condense these to 1 log. So I'm going to have 1 log, okay? They're subtracted, which means that this first argument is the numerator and the second argument is the denominator. And that equals this log over here. Okay. Now, this is great because if I have log equals log, guess what happens to the logs? They cancel. All I'm left with is x plus 6 over 2 equals 4x plus 2. Awesome. Okay, here's my LCD. I want to get rid of this fraction, so I'm going to multiply both sides by 2. This cancels, and I get x plus 6 on the left, and I'm going to get 2 multiplied by that parenthesis on the right. Okay. I'm going to take this 2 and I'm going to distribute it through that parenthesis. And now I'm just going to solve. I'm going to subtract x. I get 6 equals 7x plus 4. I'm going to subtract 4. I get 2 equals 7x. I'm going to divide by 7. And my answer appears to be 2/7. Now, before I circle it, I need to check and make sure this gives me a positive argument. If I plug in 2/7 plus 6, I don't know what that is, but it's positive. Nothing to plug in here, 2 is positive. 4 times 2/7 plus 2, I don't know what that is, but it's going to be positive. That means we're good to go. And those are our answers. Okay, now remember, all your answers are in the back, so you can look through and check it. I would strongly urge you to be able to go through this entire study guide by yourself without any prompting from this video or me, and make sure you get all the same answers. Also, make sure you have it ready, so when you take your test, you can always look back, right? But you need to be ready to go. I will be looking through your answers after my math lab grades it. Before I put them in the grade book, I will go back and look at every answer that was missed to make sure that it wasn't something silly. I know my math lab is a pain in the butt, so I will check it. And then once I've done that and I'm happy with them, then I will make sure they get put in the grade book for you. So your test will be open Thursday morning early. You have all day Thursday, all day Friday. Only 1 attempt. You have 2 hours to do these 13 questions. Please email me or text me or call me if you have any questions about this at all. I updated all my instructor information there on our Blackboard page, so my cell phone number's on there if you need me. Otherwise, good luck to you, and then next week we will start studying for the final. So, and make sure you get all your My Math Lab handled, because that will expire Sunday at midnight, and I cannot turn that back on for you. So please, please, please go on there and do that. Okay, I miss you. Stay healthy. Bye.